Hi everyone, today I'm going to talk about dot product, more specifically the applications of dot product. Now the first application of dot product, and which is what we mainly use dot product for, is to find the angles between two vectors. Now in dot product, this is the main formula, the main and most important formula, which is a dot b equals to mod a mod b cosine theta. Then rearranging it, we get cosine theta equals to a dot b mod a mod b. Okay. Then why do I put a modulus sign of this? The modulus sign allows us to find the acute angle of it. So if the question asks for acute angle, by putting the mod sign, you're guaranteeing yourself an acute angle. Why is this the case? Now in our secondary school math, we have learned ASTC. Okay, and when is C positive? C is positive in the first quadrant and fourth quadrant. Okay, I'm sorry, when is cosine theta positive? First and fourth quadrant. But in vectors, right, vectors we just take it as 0 degrees theta 180 degrees, that's within this range, because even it goes to C, right, we can just take the smaller angle. Okay, so we just take it this way, so we don't care about the C, we care about the A and the S, the first and the second quadrant. And this one guarantee ourselves, since by the modular sign, right, if you find the theta, it will just guarantees us the acute angle of it. But what if the question asks for an obtuse angle? Then the obtuse angle is where cosine theta equals negative, so it will lie at the S part. Then obtuse angle, we cannot just straight away find. Obtuse angle, we need to find the alpha first, remember, okay? We need to first find the alpha before we minus, then we take the 180 minus the alpha. Okay, you cannot just straight away, oh, negative, so I just inverse cosine that. Nah, that's not how it works. Then the second application of dot product is the length of projection. Now, what is the length of projection? Now, length of projection, normally we just think to ourselves, oh yeah, length of projection, right, easy lah, equals to mod a dot b over b mod b. Wow, easy, right? Just put the formula. No, length of projection, right, although in math there's a lot of concepts that we understand very little, but we just apply. But I think this one is simple enough for us to understand what we're actually applying. So let's look at this triangle, right? Now I don't find mod A. Mod A is basically the hypotenuse. Okay, and this is the theta here. Okay, so what is this one? This one is just mod cosine theta lah. Mod cosine theta. So length of projection, mod cosine theta. What is mod cosine theta? Length of projection. And what is length of projection? They are the same thing. The length of projection is mod A cosine theta. Okay, so they are the same thing. Then let's look at the main formula of dot product. A dot b equals to mod A mod b cosine theta. Rearranging it, we get mod A cosine theta. Mod A cosine theta. We already have mod A cosine theta. It's here. This is mod A cosine theta. Okay, so rearranging it is here. Then, hey, if this is the length, right? If this is the length, right? Then the length is just this one lah. The length of projection is this one. Then mod A cosine theta is this one. Then it's like this lah. But why do we put a mod here? Because it's length, what? Length cannot be negative one. Then what if theta is obtuse? What if theta is obtuse? Theta is obtuse, then it actually derive us the same concept. Look at AB here and B here and this theta here. Then what is this? We take this one, and this is length of projection. Length of projection here, okay? Length of projection. Then this one would be 180 degrees minus theta. Okay? Then I want to find this. Then this part is just mod A cosine 180 minus theta. Then from our trigo stuff, right? Trigo stuff, we know if we convert it, cosine 180 minus theta, it will just be negative cosine theta. Then it just be negative mod A cosine theta. Then since it's a mod, right, we don't care about the negative sign anymore. Okay? Now in our tutorials and lectures, right, we can see there's another formula for length, which is just A dot B cap. Why can this be the case? Actually, it's the same formula, you know. It's the same formula. So mod A dot B over B cap is actually just A dot B cap over mod B which is the unit vector of B lah. So it's just like this. So it's the same. Now let's talk about resolving factors. What does resolving factors mean? For resolving factors, right, is when they ask us to find the projection vector. Then the vector must be expressed in this form. Okay, x, y, z. Okay, this is the vector form. Yeah, I thought dot product supposed to find scalar one. How can find the vector? Actually, right, it's like this one. I want to find A. How do I get to point A? Point A, I want to introduce a vector A1 and a vector A2. A1 going here, A2 going here, then this one is A. Okay? We're resolving vectors, okay? We learn in physics also. We learn in physics we resolve vectors by putting this is right? It's the same concept. Okay? Same concept. Now, A1, right? How do you find the projection vector of it? I'll just show you what is the projection vector of this. This is the projection vector formula. Okay, mod A dot B over mod B. I'm sorry. Yeah, there's mod B, then multiplied with the unit vector of B. Why is this the case? Why? Actually, we have to first look at our basics of vectors. Why? Basics of vectors. So assume, right, you got a vector of A. Right? You have A here, right? Then they give you a line parallel to A, which is B, okay? And they also give you a line that has the same magnitude of A, which is C, okay? Same magnitude of A. Then, actually, to find A is essentially just mod C to give us the magnitude of A, and B cap. Then why can this be a case, right? Okay, this give out a magnitude, okay, sure. But B cap, why can put a B cap there? Wouldn't this affect the magnitude? No. Right? B cap is a unit vector. A unit vector has a magnitude of 1. So even you multiply it, right, it won't affect the numerical magnitude of it. Okay? So B cap will just provide us with the direction of A. Same concept here. Okay? Same concept here. Okay, we are given A, right, and we want to resolve. Now, what is parallel to A1? A1, which is the projection vector. Oh, B, simple. But we need to use the unit vector B lah. Then A1 has the same magnitude of A dot B over mod B, mod everything. It's just this lah. It's the same. Okay? What is this? This is the length of projection. A1 is the length of projection. A1 is just the length of projection. So it has the same magnitude. Okay? So, ta-da! You got something like that lah. Then you get A1 already. Then you get the projection vector. Then this one B cap not only provides us with the direction, it also provides us with allowing us to express it in the vector form. Okay, so it's super useful. Okay? So by this formula, very powerful. Then you get the A2, then you can find the vector of A2 as well. And that is it for application of dot product.